And we talked about trig functions before, but what's special about this section is we're finding trig functions of any angle on the unit circle, right? So the unit circle is that circle of radius 1. We had our paper plates that kind of showed us where all the angles were. And we were able to just pick an angle and figure out what the sine, cosine, or tangent was, right? You can either do it by using the unit circle or by memorizing the charts, right? So we had the chart for sine and cosine and tangent. I told you if you are a math or computer science major, you have to know the chart for sine and cosine, and everyone else has to know the chart for tangent, right? Because tangent's kind of hard to figure out without doing a bunch of math first. Okay, so we did that, and well, we haven't talked about the other trig functions, right? So we talked about sine, cosine, tangent. Haven't talked about the cosecant and the secant and the cotangent. So let's just figure out how we would do these. Any ideas on how we would figure out like cosecant, secant, or cotangent of any angle on the unit circle? So like, what if I asked you to find the cosecant of like pi over 6? What would you do? Well, how's cosecant related to sine, cosine, or tangent? Yeah, flip it, right? So we have these things called reciprocal identities, right? And what these do is they relate sine and cosecant, right? Sine and cosecant are the flips of each other. Cosine and secant are also the flips of each other. And tangent and cotangent are also the flips of each other, right? So all you have to do is flip the numerator and denominator and you've got the other one, right? So let's just do a couple examples of these. So for example, on the final exam, I might be like, find the cosecant of 2 pi over 3. And you're going to have to be able to figure out what that is, right? So what's cosecant related to? Sine, good. So maybe the first thing I should do is figure out what sine of 2 pi over 3 is, right? Okay, and you can either look at the chart and figure out the sine that way. I'm just going to take a look at my unit circle. I know that 2 pi over 3 is in the second quadrant. It's that green angle. And is sine the x value or the y value? Y value, good. So I'm just going to take a look at sine. I know that 2 pi over 3 is negative 1/2 comma square root of 3 over 2. So the sine of that is, well, the y value, square root of 3 over 2. Okay, I'm not done yet because, well, I want to know what the cosecant is. I don't just want to know what the sine is. So to find the cosecant, what I'm going to do is just flip it over. Okay, so it's going to be 2 over the square root of 3. Is that my final answer? Oh, right. There's a square root in the denominator. Whenever you have a square root in the denominator, that's not okay, right? So not simplified. And the way that we kind of counteract that is, well, you can multiply the top and bottom by the square root, right? So this is kind of like our common math trick. Multiplying across, we have 2 square roots of 3, and on the bottom we have 3, right? So the cosecant of 2 pi over 3 is 2 square root of 3 over 3. All right. Any question on cosecant? You know, I actually feel pretty confident that you could do the other ones. So why don't I give you like a couple minutes to work on the other 3, and then we'll come back in a little bit. Real quick, we want to find the cotangent of 5 pi over 3. Okay. Ainsley, you want to take us through this one? Mm-hmm. Mm-hmm. Perfect. And that's just how you do it. Any questions on the cotangent? All right. Stephen did the secant. Do you want to take us through this one?
Okay, but for real. Okay, so cosine is x over y, so
It's just X.
just
Yeah.
x. So it would be 0 for pi over 2. So the secant, you flip it, so it would be 1 over 0, which doesn't exist. Can't flip it.
Good, good. All right, now I saw some good work with the secant, but I feel like we got confused because we're dealing with a number that we haven't flipped over before. So let's just go over how we do this one, okay? Now, if I want to find the secant of 3 pi over 4, I know that secant's related to cosine, right? So I definitely want to find the cosine of 3 pi over 4 first. Okay, now taking a look at my unit circle, looks like 3 pi over 4 is in the second quadrant, right? And the x and y values for this are negative square root of 2 over 2, comma, square root of 2 over 2. Okay. Now, just like in the last question, I know that cosine is the x value, right? So it's pretty easy to see that cosine is going to be negative square root of 2 over 2, right? Okay, so I know this value pretty easily. Now I want to find the secant, okay? And I know the secant is just flipping it over, right? So negative 2 over root 2. Is that my final answer? No, because, oh, there's a square root in the denominator, right? Can't have a square root in the denominator. I know that we've only really been multiplying the top and bottom by like the square root of 3 these days, but we can still multiply by the top and bottom by the square root of 2, right? Because, well, that's the thing in the denominator. I know it's very tempting to start crossing things out, but if you do that, you'll kind of like cycle around to what you started with. So let's just multiply all the way across. We got negative 2 times the square root of 2, and that is 2 times the square root of 2. What's square root of 2 times square root of 2? Just 2. Good. Okay, so I saw some answers left like this, which is fine, but is there a way I can simplify this?
Cross out the 2 on the top and bottom, and you're just left with negative square root of 2.
Perfect, right? There's a 2 on the top, there's a 2 on the bottom. I can cross those out, and I'm left with just negative square root of 2. So that would be my final simplified answer. Any questions on this one? All righty. So I think we're pretty comfortable with finding like secant, cotangent, things like that. Let's make it a little bit harder. Right? Yeah.
Good question. On the secant pi over 2, I don't understand what the person wrote on the top with cosecant.
Oh, so you're asking what this is?
Yeah, like I don't understand because the handwriting is a little messy, so it's like I can't see that.
Oh, okay. This is cosine of pi over 2. So it's just cool.
Because I was like, what the heck is that?
Oh, don't worry about it.
Is that a minus?
No, this is an equal sign.
Oh, okay. Got you. Okay.
All right. All right, so let's go on to the next question here. We're going to make it a little bit harder. And let's take a look at this example. So in this example, we have a right triangle. So we're back to those sorts of questions where we have to maybe use the Pythagorean theorem, right? Or not. And we have a triangle. And usually when we have a triangle and we want to find a side length, we're given 2 side lengths and we're trying to find the other side length, right? That's usually what we're given. This time, we're only given 1 side length, which is kind of weird, right? But we actually are given some information. We're also given that this angle here is pi over 6. Okay, so we are given some information here, but it's not what we're used to seeing, okay? Since we want to do this, maybe we can apply our knowledge of like sine, cosine, tangent to figure out what these side lengths are going to be, okay? So when I do this, the first thing I'm going to do is just label my side lengths, right? I know that the angle I'm looking at is this one because, well, that's the only angle that we're given. I know it's pi over 6, okay? And I know that the longest side is the hypotenuse, right? So I know that side is called the hypotenuse. Since we're focusing on pi over 6, I know that the bottom angle or the bottom side length has to be the adjacent, right? Because the adjacent is the length or the side length that is like adjacent or next to the angle. Okay. Now, finally, the side length that's opposite to the angle is called the opposite. Okay, so we're going back to that sort of definition of sine, cosine, and tangent. Okay. Well, why don't we just write out a few things? We know that we can find the sine, the cosine, and the tangent of any angle. And since we're focusing on pi over 6, why don't we just figure out what sine of pi over 6, cosine of pi over 6, and tangent of pi over 6 is, right? That is pretty useful to us. Okay. Now, when I do this, take a look at your unit circle. I know that pi over 6 is an angle that has square root of 3 over 2 comma 1/2 as my point. I know that sine of pi over 6 is the y value, or 1/2. I know that cosine is the x value, or square root of 3 over 2. And tangent, you can do y over x, or you can just know that it's square root of 3 over 3, right, using the chart. Okay, so I know that these values are true. Okay. Now, let's take a look at the triangle and see what the triangle tells us. Okay. Now, the angle is this one, and I'm trying to find the sine of that angle. What's another way of finding sine in reference to a right triangle? It's the first part of SOHCAHTOA. Good. We know that we don't just know that sine of pi over 6 is 1/2. We also know that based on the triangle, sine is opposite over hypotenuse. Okay. And well, let's take a look at this. Opposite angle we said was 4, right? And the hypotenuse angle we said was x. So I know that sine is both, and let me highlight the important parts of this. I know that sine is both 1/2 and 4 over x. All right, let's keep going. I know that cosine is adjacent over hypotenuse. Okay, so well, I know the adjacent is y. I know the hypotenuse is x. Okay, and I know that tangent is, well, gosh, I'm very bad at SOHCAHTOA. I don't do it that way, but opposite over adjacent, right? So I know that tangent has to be 4 over y. Okay. So what we've done is we set up this thing that we call a chain of equalities. I'm used to saying chain of inequalities, but this is called a chain of equalities. Okay, let me write this out. Chain of equalities. And the reason it's called a chain is because we have a long string of things that are all connected by equal signs, right? So I know that 4 over x is the opposite over hypotenuse. And I know the opposite over hypotenuse is sine of pi over 6. And I know the sine of pi over 6 is 1/2. But if these are all equal, I know that if I take any two things in this chain, they're still going to be equal, okay? So I know it looks kind of funny at first when you do this, but I can take anything in this string of equal signs and I can set them equal to each other. And I think an easy thing to do here would be to set 4 over x equal to 1/2. Does everyone see how I did that? All right. Well, once we have this, this is just an equal sign, right? We can solve this like a normal equation. Any ideas on how to solve this? I know it looks funky.
I would say the multiply 1/2 by 4.
That actually wouldn't work because if I multiply 1/2 by 4, let me show you what happens. You have to do it on the other side and then it doesn't really help, right? Anyone heard of cross multiplication?
Oh, that.
Yeah, there is a way to algebraically solve it, but I think cross multiplication is the easiest thing to do here. Okay, so let's just review that real quick. Cross multiply. Whenever you have like one fraction equal to another fraction, you can do this thing called cross multiplication, which is just a bunch of algebra steps in one step, basically. And what we're gonna do here is, let me do a different color, okay? I'm just gonna multiply across the diagonals, okay? So 4 times 2 is 8. X times 1 is X. Just set them equal to each other. Does that kind of make sense? All right. And well, we actually don't have anything to solve because, well, I know that X equals 8, right? I don't have to solve anything else. So I know that the value of X has to be 8. So that's 8. All right. Any ideas on how to get Y? Oh, yeah.
On the last one, you just multiply top and bottom on that by 4 to get 4/8, and then you number will have to be 8 that way.
So you're like, okay, I know. So are you still talking about how to solve this?
Yes.
Yeah. So I think Ainsley was like, okay, I can solve this like a normal equation and do like multiply by 2 on both sides. Is that what you're saying? And
Multiply by 4, like,
oh, multiply.
or X is 1/2.
Oh, I see what you're doing. Okay, you know what, Steven, that actually would work. It'd be 8 over X. No, sorry, 4 times 4 is 16 equals 4 over 2.
8.
Wouldn't be over 8 though.
I just multiplied the other side by 4 to get 4/something.
Okay, but then it'd be 4 over 2.
4/8.
It'd be 4
Oh.
over 2, right? So when you multiply the numerators together, but not the denominator. Now there is a way to algebraically do this. Let me just show you, and you don't have to write this out. This is what I would do if I didn't cross multiply, okay? So I know it's kind of confusing, all right, when we have fractions and things like that. The first thing I would do is, I know that there's a 2 in the bottom and an X in the bottom. So what I'm gonna do is just multiply by 2. That seems like a good idea, right? If I do that, then the 2's will cancel. So on the left, I'd have 8 over X equals 1, right? Then I know that there's an X in the bottom. So what I do to get rid of it is multiply by X on both sides. So that would give me, the X's cancel out, and I'd have 8 equals 1 times X, which is X. So that would be like the more algebraic way to go about it. Now there is a way to maybe make the numerators equal, and then you'd know what the denominator is, but
That's what I, yeah.
I think with,
I'll look at what I did, like what you worked out, because
yeah,
so,
yeah, let me see what you did. Let me undo this. Just take a look. So I think there's multiple ways to do this. I see, okay. Okay, that's actually good. Okay, let me show this way. Okay, I see what you did now. Okay, so let me show you a third way to do this. So there's multiple directions we can go here. So we can start with our original equation. And Ainsley's like, okay, I need the denominator or the numerator to be 4, right? Because if the numerators both are 4, then the denominators have to be the same. What she does is she's like, okay, I'm not gonna multiply by both sides. I'm just gonna multiply 1/2 by 1, okay? Another way of writing 1 is, well, 4 over 4, right? I can do that on one side because I'm just multiplying by 1. It's not doing anything to the left side, okay? All right, well, multiplying across, we got 4 over X equals 4 times 1 is 4, 2 times 4 is 8, okay? And now we have a fraction where both the numerators are 4, which means the denominators have to be the same if they're equal, right? So because this is true, then I know that X has to be 8. Okay, so that's another way you can go about this. All right, so 3 different ways we can solve this equation. All right, any questions on this part? So I'm gonna write Ainsley. All right, So now that I know that x is 8, I know the hypotenuse is 8. How do I go about finding y?
I would say the tangent.
You need a tangent.
I was gonna just say. So just y squared plus 4 squared equals x squared. Solve that down.
I see. So it looks like, okay, so finding y. I got two good ways of finding this, right? So what Stephen said is use the tangent, right? So use 4 over y equals the tangent square root of 3 over 3. Okay, so that's what Stephen said. What Robert said is, why don't we just use the Pythagorean theorem, right? We can also use a squared plus b squared equals c squared. Okay, either one of these is a totally good way of finding what y is. Since we're not used to cross multiplying, let me do the tangent version. But if you feel comfortable doing the Pythagorean theorem, you'll still get the right answer. So either way works. I'm just going to use this one because, well, we're not used to seeing that. Okay. So from the tangent, I know that 4 over y equals root 3 over 3. Okay. Let's do the cross multiplication trick here. We got 3 times 4. I know that that's 12. I know that, gosh, square root of 3 times y is, well, the square root of 3y. Good. And how do I get y by itself? Well, square root of 3 is multiplied by y. How do I undo multiplication? Division, right? So if the square root of 3 is multiplied by y, all I have to do is divide by the square root of 3. And I know that y is equal to 12 over the square root of 3. Is that my final answer? No, because there's a square root of 3 in the bottom, so I gotta multiply by root 3 over 3, and I'm gonna get 12 root 3 over 3. Okay, now that is an answer. Any way I can simplify it more? Yeah, there's a 12. Oh, I can't cross out the 2 3s, right? But
You divide 12 by 3.
yeah. I can do 12 divided by 3 and get what 4 square roots of 3. Is that right?
Yeah.
All right, and let me just, yeah, that seems right to me. All right, so this is my y value. Okay, so for this answer, I have an x value and a y value, and I'm all done. All right. Any questions on example number 1?
So when I did the, I ended up getting y is the square root of 48.
So,
Is that still? correct?
Yep.
You do 4 times square root of 3 in my head.
yeah, basically 48 is, gosh, is it 4 times 12, right? No, it's 16 times something, right? It's probably 16 times 3. And the square root of 16 is 4. So it's still 4 times square root of 3. Yeah, I would mark it right. All right. Any questions on example 1? All right, I'm gonna have you take a few minutes to take a shot at example number 2. I think we have enough information to go and do that. I know that you're still working, but I want to make sure that we finish this before class ends. I don't want to hold you late on the week of Thanksgiving break. So let's just go over this one really quick. Okay, so I have this triangle. I only have one value. I'm given the angle in like the corner. So I know that like everything kind of is labeled the same, right? I have my hypotenuse. I know the opposite and the adjacent angle are there, right? So let's find sine, cosine, and tangent of each of these. So sine of pi over 4, cosine of pi over 4, and tangent of pi over 4. Okay. Looking at your unit circle, pi over 4 is the angle that has the endpoints square root of 2 over 2, comma, square root of 2 over 2. So, well, I know that the sine of pi over 4 is the y value, square root of 2 over 2. Cosine is the x value, which is still square root of 2 over 2. And I know that tangent of pi over 4 is, using my chart, it's just 1. Okay. Now, I also can figure out these angle values using the triangle, right? I know the sine is opposite over hypotenuse. So I know that sine is x over 4, right? I know that cosine is adjacent over hypotenuse. So that is y over 4. And I know that tangent is opposite over adjacent. So I know that the tangent is x over y. Okay, so I know that these relationships exist. Okay. Now, which one do you want to start with? Sine, cosine, or tangent? I don't know. Sine seems pretty good. Cosine would be good. The tangent wouldn't be fun to work with though, right? Because there's both an x and a y. So either sine and cosine, let's start with those. Using this first relationship here, I know that x over 4 is equal to root 2 over 2, right? So let me write that out. X over 4 equals square root of 2 over 2. Does everyone kind of see how I got that relationship? Good. Once we're here, you can either like solve it normally, do Ainsley's trick, or cross multiply. And I'm going to cross multiply here. So I'm going to multiply across. I know that 2 times x equals, multiplying across here, 4 square roots of 2. Okay, so that's just cross multiplying my result from there. And how do I get x by itself? Yeah, divide by 2. I know that there's a 2 attached to the x. So if I divide by 2 on both sides, I get that x is 4 square roots of 2 over 2. Okay, and well, there's a 4 and a 2. So if I divide them out, this is literally 2 times root 2. Okay, so what I have here is that my opposite side, x, is 2 root 2. Okay. Now, to find y, we do have enough information to use the Pythagorean theorem if you would like to do that. I'm actually going to work with the cosine now because, well, why not? All right, so using my information about cosine, I know that y over 4 is equal to root 2 over 2. Okay. Now I have this relationship up. I can definitely cross multiply, but what do you think y is? The same as x, right? Because if you take a look at this, isn't the equation I just wrote in pink this equation? Like it's literally the same equation, except instead of writing y, I wrote x, right? So I'm not actually going to solve it because I know it's going to be 2 roots 2 of 2 because it's the same equation. Okay, so I saved myself some work here. I found what y is, and well, that's all I need to do. All right, any questions on this example here? Alrighty, well, I actually, you know what, how about for Thanksgiving treat, I'll let you out a little bit early. We'll start with the last 2 examples next class.